After it enters your, well, before we do that, how it continues is the gametocyte, which is the sexual form. It starts developing, but it lays dormant in your body. And then once a mosquito, say the Anopheles quadrimaculatus, which is the common malaria mosquito, once it takes in the sexual form into the mosquito's body, the okinete will start forming after fertilization. There's a male and a female, and once they fertilize, they form an okinete. And the okinete, once it's fertilized, it's able to move. What it does is it actually moves to the gut of the mosquito and forms a cyst. Now, the sexual form requires lower temperatures, so the cooling of the blood inside the mosquito's body helps it develop. But the merozoites can only replicate in high body temperature. So the merozoites will actually die inside the mosquito's body and be digested with the rest of the blood meal, whereas it is able to replicate inside your body and actually cause you to become sick. But once out of your body and into the body of the mosquito, it's pretty much dead. And as I said, it will be digested with the rest of the blood meal. Now, the okinete, after it forms a cyst in the mosquito's gut, it starts replicating, it starts developing into thousands upon thousands to millions of sporozoites. The sporozoites then migrate to the salivary glands of the mosquito. And why the salivary glands? Well, because the mosquito needs to spit immunoglobulins into your bloodstream if it's to properly feed on your blood. So, it just pretty much rides along with its saliva, with its immunoglobulins in its saliva, into the host. And that's where the trouble starts again. And this is just a picture of what I mean. The first picture is a female on the left with a male sperm about to enter, and on the right of the first picture, that's actually a developing male. And same goes for the second picture at the top. And then the bottom two pictures basically show cysts in the mosquito's gut, as well as the little lines. Those little dotted lines on the page are actually the sporozoites leaving the cysts. So this is just a little bit of visuals for you. And then treatment, quinine is probably the original form, but I actually heard that quinine causes aggression and problems in people. So they're actually moving to the other forms of treatment, and you can read them yourself. I don't want to try pronouncing some of them because they're kind of hard. But this is just a new development in trying to protect people from this disease, and government support, sanitation, it all helps. Here is a list of pretty much the common carriers, the vectors of malaria. These are the mosquito species. The most probably prevalent one, actually I don't even know which is the most prevalent one, but the one I'm working with right now is the Anopheles quadrimaculatus, because it is found in the United States and it does carry malaria. So better watch out for that. Prevention of malaria, well, residual spraying, which is actually spraying inside your house or around it, usually in large apartment complexes, something like that, helps. Wearing long clothing really helps. It stops mosquitoes from biting you and transmitting the disease to you. Using insect repellent when in mosquito-infested areas. Of course, bug spray helps, getting rid of your chance of being bitten by not just mosquitoes, but other disease-spreading insects as well. And mosquito netting, if you're in the tropical parts of the world, mosquito netting blocks out the entrance of mosquitoes and you won't get bitten. Transgenic insects, they're actually developing mosquitoes, or trying to, that are incapable of carrying malaria. So that's sort of a futuristic project, and Also, I have read current events on them actually discovering a protein that falciparum needs in order to survive. So, if they can find a way to get rid of the protein in falciparum, they will pretty much die out and thus actually cure malaria. So that's just a new fun article that I read. As well as overall sanitation, everything helps when it's clean. And when everything's clean, well, you get a better chance at avoiding the disease or curing it. And then finally, the death toll. The problem with malaria and the Anopheles mosquitoes is they are found all over the world, worldwide. And even after proper sanitation skills, still about 1 million people die a year from the malaria parasite. And that's kind of unfortunate, as well as the fact that about 300 to about 500 million cases a year are reported of malaria, and probably millions more are unreported. So usually, if you can look from the map, if you can tell from the map, it's Africa and mostly Africa and bits of Asia and South America where malaria actually does do quite a high amount of damage to the local population. If you can see, there are actually sections of Africa, especially I see a few countries in Eastern Africa, or excuse me, Western Africa, where there are over 25,000 cases a year. Luckily for the United States, right now it's less than 10 cases a year, so that's a really amazing improvement than before. And just with all, everything, science helps. Science, research, discovery, discoveries in medicine, discoveries in microbiology, and genetics all help contribute to stopping this disease. And with that, I end the presentation, and that's my works cited page. So, I hope you guys enjoyed this short little lecture. If you like it, I will put on more of these. Next, I might do yellow fever and dengue probably afterwards. And I also probably might do a few on maybe genetic diseases as well. So, with all that said, I will see you guys later, and please leave a like, and please subscribe. Alright guys, bye-bye.